Good morning, students. Welcome to my channel Physics Fun Do. Physics Fun Do. Today is the last case on the connected bodies motion. Connected body motion. This is the class 11 basics. Basics. Class 11 basics. Let us consider two blocks of mass m1 and m2. They are connected by a string, and a force is applied on a string in the rightward direction. Now we have to calculate the tension acting between the blocks on the string, connecting string. So here the tension for the m1 acting in that direction and tension for the m2 is acting in opposite direction. Now considering the motion of m1, the motion of m1, first we have to find the acceleration of the system. Here the linear acceleration A is equals to force by total mass m1 plus m2. Now the tension acting on the m1 T is equals to m1 into A, that is equals to m1 into acceleration is f by m1 plus m2, that is equals to m1 by m1 plus m2 into f. That is the expression of the tension. Now let's move the three body system. Let us consider the three blocks 1, 2 and 3. They are connected by the strings and a force capital F is applied in the rightward direction. Now the mass is m1, m2 and m3. m1, m2 and m3. Now the tension acting on the mass m1 in that direction is T1. Let's consider it. And for the m2, that is T1 in the leftward direction. For the m3, tension T2 acting in that direction, and for m2 acting in that direction T2. Now first we find the linear acceleration. Linear acceleration A is equals to F by m1 plus m2 plus m3. Okay, that is the linear acceleration. Now to find the tension T1 so easy. T1 is equals to m1 into A, that is equals to m1 into F by m1 plus m2 plus m3, that is equals to m1 by m1 plus m2 plus m3 into F. That is the tension T1. Now to find the tension T2, we have to consider the resultant force. First we draw the free body diagram FBD for the mass 2. In the free body diagram, we see that the two forces acting on the mass, one is tension T2 and another is tension T1. They are in the opposite direction. So the resultant force is equals to t2 minus t1. t2 minus t1. Now from Newton's laws of motion, t2 minus t1 is equals to m2a. Now here t2 is equals to t1 plus m2a. what? तो यहाँ से let's move t2 is equals to t1, that is m1 by m1 plus m2 plus m3 into f plus m2a. m2a means m2 into f by m1 plus m2 plus m3, that is equals to m1 plus m2 by m1 plus m2 plus m3 into f. Okay, that is the t2. Now the next case is the conservation of linear momentum. Conservation of linear momentum. Conservation of linear momentum. What is the conservation of linear momentum? If the resultant force acting on the system, external resultant force acting on the system is 0, then the total linear momentum of a system of particles are conserved in a definite direction. Now let us explain it. How to explain it? Let us consider two objects of masses m1 and m2. This is u1, this is u2, moving in the same direction. Here the collision happens. Then they are moving with the velocities v1 and v2, mass m1 and m2. The linear momentum of the first object is m1 u1, for the second m2 u2. Now here u1 is greater than u2, so the collision has happened, and here v2 is greater than v1. Now m1 v1, that is m2 v2. Before the collision, total linear momentum in a definite direction, and after the collision, the total linear momentum is m1 v1 plus m2 v2. Now takes the vector sum, this is v1 u1 v, this v, this v. That will be equal. That is pi of 1 plus pi of 2. That is the initial linear momentum. That is equals to pf of 1 plus pf of 2. Okay. Now prove conservation of linear momentum from Newton's second law of motion, NSLM. So Newton's second law of motion. If the total external force acting on the system is 0, so F ext is equals to 0. Okay. Now they know that the force is equals to a rate of change of momentum, that is dp by dt. That should be equals to 0. Now here dp is equals to 0 dt. Now integrating both sides, integration of dp is integration of 0 dt plus c. So here p is equals to c. That is, the linear momentum is constant. Now to prove it, for the Newton's third law of motion, Newton's third law of motion. Third law of motion. Newton's third law of motion, how to prove it? Take the objects moving linearly with the velocities u1, u2, mass m1, m2. And here the collision happened, collision. And in the collision there is the impulsive force m2, m1. Here the force is F1 and here the force is F2. That is, the second object gives the force of F1 on the M1 and M1 gives the force on M2 is F2. And after collision, the velocities become V1 and that is V2. Okay, here U1 is greater than U2. So the collision happened and V1 is greater than V2. Now if the second object gives an impulsive force on the first object, then we have F1 is equals to rate of change of the linear momentum of the first object, that is m1 v1 minus of m1 u1 by t. Now the first object gives the impulsive force on the m2, then F2 is equals to m2 v2 minus m2 u2 by t. Okay, now the every action there is equal and opposite reaction. So F1 is equals to minus of F2. Now putting it, m1 v1 minus m1 u1 by t, that is equals to minus of m2 v2 minus m2 u2 by t. T will be cancelled out. So we have implies m1 v1 minus m1 u1 is equals to minus plus minus m2 v2 minus minus plus m2 u2. So m1 v1 plus m2 v2 is equals to m1 u1 plus m2 u2. Okay now, that is the conservation of linear momentum. Now let us consider the explosion. Let us consider the explosion of bomb. Explosion of bomb. When we consider a bomb, its linear momentum initially is 0. Now after explosion, let us consider the formation of the 5 fragments. That is, the linear momentum of first is P1, P2, P3, P4 and P5. Here the total linear momentum, that is P1 plus P2 plus P3 plus P4 plus P5 should be equals to 0. So that is the all for the day. Stay tuned and we will soon come with the next topics. Please share, subscribe, and give your valuable comments. So goodbye.